Alright, let's look at homogeneous linear equations with constant coefficients. Alright, so the form of the equation looks like this. Ay double prime plus by prime plus cy is equal to 0. Alright, so what we want to do is we're going to look for a solution of a particular form. So here, so we're going to look for solution of the form y equals e to the rx. Right? Then we need to take the derivative. So if you take the derivative of y, you get the y prime is equal to e to the rx multiplied by derivative inside. So it's going to be r e to the rx. And the second derivative would be, right, we take the derivative again. So you're going to end up getting r squared e to the rx. Right? Then if you plug all these back into the original equation, you're going to end up getting this. So you have a times y double prime would be r squared e to the rx plus b times, right, y prime is r e to the rx and plus c times e to the rx. And this is going to be equal to 0. Right? And since e to the rx is a it's actually a positive quantity, so I'm going to actually divide through by e to the rx. And then what you end up getting is a r squared plus br plus c is equal to 0 divided by e to the rx is going to be still equal to 0. Alright, this equation is called the characteristic equation. So let me write that, characteristic equation of this differential equation. And since this is just a quadratic equation, we can find solution. Let's say you have two solutions, r equals r1 and r2, right? So if you have distinct real roots, r1 and r2, then you can see that the solution, so general solution is going to be y equals, right? If you use r1, so you're going to have a solution e to the r1 x. And using r2, you're going to get e to the r2x. And remember that any linear combination of solution is also a solution. So I'm going to make the linear combination. Right? So this is going to be a solution when you have distinct real roots. So this is the case right here. When you have two distinct real roots, right, then you can see that the solution is going to be simply y is equal to c1 e to the r1 x plus c2 times e to the r2x, right? So let's look at that simple example here. Right, so here's an example. Right, so first I'm going to turn it into a characteristic equation. So characteristic equation is going to look like 2r, so second derivative squared, plus 3 first derivative, so it's going to be r, is equal to 0. Right, then you can factor out r. Then you have a 2r plus 3 is equal to 0, right? So we're going to have two values. So you have r is equal to 0. And if you set this 2r plus 3 equal to 0, you're going to get the negative 3 halves, right? Then the solution is going to be, so here, so therefore, right, so you're going to have a y is equal to, right, c1 times, right, so e to the 0x is going to be 1. So it's going to be c1 times 1 plus c2 times e to the negative 3/2 x. Right? So this is going to be the solution. So this is the solution of the given differential equation. Right? How about okay, so if you have two real roots, this is pretty easy. You just have to do c1 e to the r1x plus c2 e to the r2x. What if you have a repeated roots of, right? So here, let's say if you have a duplicate real roots, right? So r1 and r2 are roots, but the r1 happens to be equal to r2. Alright, if that's the case, we have to do a little bit slightly differently. So you have solution is going to look like this. Let's see. Alright, it's going to look like y is equal to c1 e to the, of course, r1x. That's the first one. Second one, we cannot use r2 because r2 is actually the same number as r1. So what you do is we're going to have to actually multiply by x. So it's going to be c2 x times e to the r1 or r2x. That doesn't matter because it's the same number. Right? So that's going to be the form of the solution. Right? So let's look at the following example. Right? So here. Right, I'm going to bring it out. Right, so if you turn this into a characteristic equation, what you're going to get is, so characteristic equation is, let's see, 9r squared minus 12r plus 4 equals 0. Right, then we can just factor this out. And I think this is going to factor out as a 3r minus 2 squared. That's equal to 0. Right? So then you're going to get the r value, which is going to be 2/3. Right? Which is repeated. Alright? Then what you can do is the solution is going to be y is equal to, right? It's going to be c1 e to the 2/3 x plus c2 x times e to the 2/3 x. Right? So that is the solution when you have one duplicate real roots. Right? So we're going to do other cases where roots are complex numbers, but we'll do that for later. But when you have a real roots, then the first case would be you would have distinct roots, and you have the case example 1. And when you have a duplicate roots, then you would have to have the second solution is going to be x times e to the r1x. Right? That's the only thing you have to do it differently. All right, that's it. I hope that this was clear.